In this video, we'll look at a different approach to long division, which we'll call the method of decomposition. In this method, we'll decompose the dividend into a set of numbers that sum to the original. By decomposing the dividend, we can form a set of problems that are smaller and easier to calculate. As an example, we'll use 35 divided by 3. Using our knowledge of number decomposition, we know that 35 can be broken up in a number of ways. For example, 35 is equal to 1 plus 34, or 2 plus 33, 3 plus 32, etc. A good way to break this up might be to take 35 is equal to 33 plus 2. This makes our problem 33 plus 2 divided by 3, which by the distributive property gives us 33 divided by 3 plus 2 divided by 3. From here, it is clear that 33 divided by 3 is equal to 11, and that 2 is not wholly divisible by 3, so this becomes our remainder. So we know that 11, remainder 2, is our quotient. Though any decomposition will work out in the end, some decompositions aren't as clean or easy to compute as others. Some intuition is needed to see which decompositions will provide for easier calculations. For example, what if we decomposed 35 into 20 plus 15? By the distributive property, this would give us 20 divided by 3 plus 15 divided by 3. Now we know that 20 is not wholly divisible by 3, so let's decompose it further into 15 plus 5. This gives us 15 plus 5 divided by 3 plus 15 divided by 3, which by the distributive property again yields 15 divided by 3 plus 5 divided by 3 plus 15 divided by 3. From here, it's relatively clear to see that 15 divided by 3 is equal to 5. But what about 5 divided by 3? This can be decomposed further into 2 plus 3 divided by 3, which by the distributive property gives us 2 divided by 3 plus 3 divided by 3. From here we know that 3 divided by 3 is equal to 1, and 2 is not wholly divisible by 3, which gives us our remainder. So adding together all of the multiples from each step, we see that 5 plus 1 with a remainder of 2 gives us 11 remainder of 2. So we can see that this decomposition will still give us the same result. We still came out with an answer of 11 remainder 2. It's just less elegant and takes a few extra steps. From these examples, we can extrapolate a general algorithm. First, we decompose the dividend into a sum of smaller numbers that contain multiples of the divisor. Using the distributive property, we distribute the division operation. Then, sum together the result of each smaller division problem. If there is a term where the dividend is smaller than the divisor, such as 2 divided by 3, this becomes your remainder. It should also be mentioned that these decompositions can be just as correctly and easily performed using subtractions rather than additions. For example, we can decompose 35 into 36 minus 1 divided by 3. By the distributive property, this gives us 36 divided by 3 minus 1 divided by 3. From here, it's clear to see that 36 divided by 3 is equal to 12, so this gives us 12 minus 1 divided by 3. Now thinking about what this answer means, we have 12 equal groups of 3, and we need to subtract a remainder of 1. So this will give us 11 equal groups of 3, with then one group that is 1 taken away, or it only has 2. So this should give us 11 groups of 3 with a remainder of 2.